Hi guys, I am Dr. G. Srinivasa Gupta, Professor, VJEC Institute of Technology from Mechanical Engineering Department. Today I am going to give a small concept on gyroscopic motion in naval ships. As you are aware that gyroscopic action and reaction, as gyroscopic action is the tendency of a rotating body to resist any change in the direction of its axis of rotation when subjected to an external force. It has been when spin axis is going to be rotated with respect to any perpendicular axis. In other third perpendicular axis, it is going to act a couple that is called gyroscopic couple. This gyroscopic couple we can estimate it by using the relation I omega s omega p. Omega s as usual meaning you know that omega is angular velocity of spinning body or spinning axis, and omega p is angular velocity of precession which is given about perpendicular axis rotation. Then third perpendicular axis, it is causing a gyroscopic action that is called gyroscopic couple. The exact meaning we want when the axis is forced to turn, the rotating body produces a resisting couple. This resisting effect is called gyroscopic action or gyroscopic couple. Based on the Newton's third law, as you know that every action there is an equal and opposite reaction. So the rotor experiences a gyroscopic couple. The bearings and frame experience an equal and opposite couple. That is, opposite couple is called gyroscopic reaction. Action and reaction. Because of action, body try to tilt in one direction about third perpendicular axis. Because of reaction, the body is going to come to in other opposite direction. So it may maintain stability. Now we are going to see this gyroscopic effect on naval ships. For this, one should understand the important terminology involved in naval ships. Let me draw a very concise, brief naval ship diagram. As you know that this naval ship, this is the ship, front view let us say, and top view if you want to see, then I will show you top view. Let us say like this. Okay, I am not that perfect in drawing. You might have understood. Then the terminology in that is this is front view, this is top view, this is front view. Okay, so the front end of the ship, if you observe from the front of in this front view, this is called bow, B-O-W, and rear end of the ship is called stern or aft, stern or aft, S-T-E-R-N, stern or A-F-T, aft, rear end. And if you view from top view, from top, the top view, the right side of, if you stand at stern and backhand, then right side portion is called starboard. Starboard, right side is called starboard, and left side is called port. Okay, so the ship contains, you might have understood, the ship contains all the rotating bodies, that is motor and to propel that. Then let us take, this is the rotating masses, motor and everything rotating in with respect to x-axis, means spinning axis. So a rotor is rotating with its own angular velocity, that is omega s, as usual notation we are using. Then perpendicular, about perpendicular axis, that is let us say these three axes, let me represent y-axis, z-axis. Then if you try to if ship is going to take from top, if you observe either left or right turn, that means starboard side or port side, then there will be a effect of this gyroscopic effect which causes about y-axis the ship is going to rotate. So the terminal used here is, if about x-axis the ship is going to roll, then this is called rolling. If about z-axis it is going to rotate, then it is called steering, left or right. And about y-axis, if it is going to rotate, this is called pitching. These terms also we need to just understand. Rolling, turning about z-axis, rolling about x-axis, pitching about pi, pitching about y-axis. So either way, if it is rolling a rotating body, spinning body, if you apply any about one axis, just try to rotate, then about third axis it causes some gyroscopic action. So now with this concept, we are going to attempt. If you understand this terminology, it's easy to understand. Let us take one numerical exercise problem, how to solve this one using the basic relation gyroscopic action and reaction, that is I omega p omega s omega p. And what is the reaction? Directions also we can understand. Let us take that, or before that, just let me say, suppose if you from rear end, that means turn, if the rotating bodies are rotating clockwise, then angular velocity vector is away from the wheel. That is omega spin angular velocity we can represent OA. Then about z-axis, we are going to give some turn, that is rotation, that turning action. Let us say it is going to turn, this entire spin axis going to rotate about z-axis. Let us say OB vector representing that rotation. Then delta theta angle rotated, delta t time, let us say. Then the change in angular velocity leads to angular acceleration. From that we can find the gyroscopic action or couple. This angular acceleration is A to B, that is gyroscopic couple is acting A to B. You can understand A to B means this is, if you apply right hand screw rule, if you rotate it clockwise from about x-axis, then it is going to rotate, means the ship is going to action of pitching. Okay, because of this z-axis motion given and the rotating bodies are rotating about x-axis. This is pitching. Reaction is opposite. Let us say B to A. This is reaction as per Newton's third law. That means there will be a rear end is going to this is anti-clockwise. It should be rotation. Reaction rotation is anti-clockwise. Rear end is going to come down and front end is going to move up. Yeah, with this understanding of terminology in naval ships, that front end bow and rear end stern and aft, and if you observe from rear end, the right side is called starboard, left side is called port. With this understanding, and the naval ships, the turbine rotor is going to rotate with about x-axis, let us say. Okay, then if we give about y-axis, this is x-axis, this is z-axis, let us say, this is y-axis. So about y-axis, if you give any motion, that is pitching. So in this problem, it is rotor is rotating about x-axis, that is omega s, spinning angular velocity. Then here we are going to give the pitching. Okay, that is. Then about third axis it is going to rotate because of gyroscopic couple. Then reaction causes opposite rotation. We will see in this problem. This is a naval ship has a turbine rotor of mass. Mass is given. Mass of the rotor M equal to 3500 kg. You can see here also. And radius of gyration R is 0.4 meters. From this data up to from this two data points, then we can calculate mass moment of inertia of this rotating bodies, spinning bodies, that is m r square. Okay. Then the rotor rotates at 2000 rpm clockwise when viewed from the stern. So it means you are observing from the rear end, it is rotating clockwise. Then from this what you are going to get spinning angular velocity, because radians per second it is rpm given. So 2 pi n by 60 will give omega s. Okay, are you able to understand about rotor? Rotating in rpm given. So you are going to get omega s. Now coming to what type of motion is given about y-axis, because pitching it is. The bow moves up and down such that the ship completes one pitching oscillation in 12 seconds. So time period is given 12 seconds. Okay, in case of pitching, generally pitching motion is considered as simple harmonic motion. Simple harmonic motion, we can write some expression of amplitude as this. Let us say at any angle of rotation, the amplitude of moving up or down can be written as okay, this lowercase letter x equal to x sine omega naught t. Are you able to understand? Here omega naught is simple harmonic motion. We can assume that a body making circular motion, let us say, then it because oscillation some circular power motion. So it is angular velocity omega naught, it is rotating. Then okay, this radius of this circle will give maximum amplitude, and if you project this point on mean position line, then this is amplitude at any rotation. So that is this x. This x is maximum amplitude, this radius, and omega naught is, it is rotating in circular motion with angular velocity omega naught, and the time period is given this much time, how much it is going to, okay, we are going to calculate omega naught. Omega naught how much if it is rotating, so omega naught we can calculate 2 pi by time period. Okay, and what else given? The maximum angular displacement during the pitching is given. Okay, let us say pi 6 degrees. So this always one should use in radians. So this 6 degrees 6 into pi by 180 will give in terms of radians. Similarly, amplitude relation given x equal to x sine omega naught t. Similarly, rotation angle, pitching angle at any position, it can be written as pi naught sine omega naught t. Okay, this is rotation angle about y-axis, that is pitching. So pi is maximum angle of rotation. So what do you want exactly? The precision angular velocity due to pitching. So that you need to get omega p. How do you get omega p? D theta by dt. So pi cos omega naught t, d theta by t dt will give pi cos omega naught t into omega naught. So because here it is maximum angular displacement it is said, then to have omega p also maximum, so cos omega naught t must be 1. Then pi omega naught you need to calculate as omega p, pi omega naught. Pi is 6 degrees in radians, you will convert. Omega naught is 2 pi by t, time period 12 seconds given, so we will get omega p. So gyroscopic couple we can estimate using the relation I omega naught omega p. Gyroscopic action or couple I omega s omega p, as you know that. So once you calculate this numerical values, calculated values also mentioned in this, you can see omega s is 209.44 radians you will get, and you can also see that omega mass moment of inertia also calculated, that we are going to get 560 kg meter square, and omega p is pi into 2 pi by t. So pi you get in the radians, if you convert to 0.1047, and 2 pi by t is 12 seconds given. So omega p you are going to get 0.0548. Then you can calculate gyroscopic couple 6.42 kilonewton meter. Actually it is kilonewton meter, not by meter. Okay, it's just a mistake. Okay, anyhow, so 6420 Newton meter. This is direction. If you want to observe direction, rotor rotates clockwise and viewed from the stern back rear end, as you know that ship is pitching. So bow is moving because of gyroscopic couple. Okay, I will draw a diagram here also. Omega s, let us say omega s in this direction. So if you, let us say, if you observe from rear end, then about transverse axis pitching, it is moving. Okay, bow is moving down, moving up, and stern is moving down. Let us take this case. Then this spinning axis will rotate. Okay, in this direction. Then let us say initial angular velocity vector OA, and after rotating, after pitching, angular velocity, okay, OB. Then the change in angular velocity is angular acceleration. This leads to gyroscopic couple. So A to B vector A towards B means if you rotate clockwise, it will move away from this A, then this is gyroscopic couple. What is going to happen? This clockwise means bow is moving down and stern is moving up. But gyroscopic reaction, if you take reaction, what happened? Because this effect, gyroscopic reaction means opposite. That is B to A. B, let us say B dash to A dash. What is going to happen? Stern is moving up, bow is moving up and stern is moving down. This is reaction. So that the ship is going to maintain in moving in horizontal position, that is stability. Okay, with this I am concluding here this gyroscopic effect on naval ships. In next lecture we are going to see gyroscopic motion or gyroscopic effect in case of automobiles. Okay, so thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.